Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on spiral matrix. We are given a matrix and we have to print it in the spiral manner, like 1, 2, 3, 6, 9, 8, 7, 4, 5, like a spiral, right? So let's just quickly jump into the problem statement, understand it and start coding. Okay, last time we have solved string to integer, and let's start with spiral matrix. Okay, given an m cross n matrix, written all elements in the matrix in spiral order. Okay, very simple problem statement. From the example we can clearly understand it. We have to return 1 2 3 6 9 8 7 4 5. Similarly for this one, 1 2 3 4 8 12 11 10 9 5 6 7. So before I go on and start explaining, please take a minute and think of the approach that you will take. Ready? Okay. So this is actually a very simple problem statement, right? As of now, we have solved roughly 52 problems as of now, and I'm sure by now you are very well versed with the coding standards and how to code even very complex problems. So this is actually very easy problem. Now what we're gonna do is, we can see from this diagram that, or let's pick this diagram. Okay, that first we are going to print the complete row, okay, the top row. Then we are going to print the complete rightmost column. Similarly after that we are going to print the complete bottom row, then the leftmost column, then the row again, top row again. But that would mean that we should reduce the value or increase the value, change the value of the top row such that we don't go to 1 after 5, right? So we go only up till 5 and then read the complete row. And also we don't reach till 8, so we have to change the right column limit as well. And similarly we have to update bottom row and left column as well. Okay, so we need to keep some pointers in all the directions such that we can execute it, right? But otherwise we just have to traverse in all the 4 directions and we'll simply keep upgrading the rows. So let's say we have top to check the top row, bottom to check the bottom row, right to check the right column, left to check the left column. After traversing once through the top row, we'll increase the value of the top row from 0 to 1, so that next time we only go till 1 and do not go for 0. Similarly, if we have a very big matrix, this will help in going in the spiral manner. Okay, let's start with coding. Now first let's make the result integer. Result is equal to new array list. Okay, we'll do a base check for empty matrix. So if matrix is equal to null, or matrix dot length, that is the row, is equal to 0, or matrix of 0 dot length, that is the column length, is equal to 0. In either of this case you can simply return blank result, right? Otherwise int m is equal to matrix dot length, I'll call it number of rows, and int n is equal to matrix of 0, that is 0th row dot length, that is number of columns. Okay, now we'll create 4 variables for top, bottom, right, left, right? So int top is equal to 0, because we'll start this as the first row. So first row, second row, third row, so this row is 0th index row, right? Similarly we have int bottom is equal to, now bottom would be the last row, so last row can be found out by m minus 1, right? Similarly we have int left, that is the first column, so int left is equal to 0. and int right, that is the rightmost column. So we are checking the column by n minus 1. Okay, that's it. I'll just comment for everyone. So this is the top boundary. Oops. This is the bottom boundary. This is the left boundary, and this is the right boundary. Okay, now we'll start with the traversal. So from where should we start? We need to check for few base conditions, otherwise we are going to run it in a while loop, right? We'll run it for a while loop and we'll check for the base condition. So base conditions would be while top is less than equal to bottom, right? Because once we have reached the final row and we have covered the top row, the bottom rows, we don't need to move forward. Similarly, we have to check and left is less than equal to right? Then we can start. Let's say we'll traverse the top first. Traverse the top. Okay, we'll use for loop for int I is equal to left, because we have to start from the left side, and plus it will be updated every time. Left I is less than equal to right I plus plus. Okay, we can simply say result dot add, and we'll add matrix top and I, right? Because for row we are using since we are traversing for the top, only the top row, so the first part, that is usually is the ij matrix, right? The row will be constant, that is the top row, and the column will keep changing based on the I from left to right. Okay, and once we have traversed this row, we'll update the row to top plus plus, so that next time when we are coming from the bottom, let's say n minus n minus 1, we'll only go till 1, will not go for the 0th row, we'll only go till first row. Now that top is 1 plus plus, right? Because similarly we need to go for the right side matrices as well, and then left side matrices as well. Okay, now we have traversed the top, we'll traverse the right side, right? So we will say for, now where to start from? We have to start from the top, because top was the last value. We don't want to print 4 again, we have updated the top, so we'll be starting from 8 now. So we can say int I is equal to top, I is less than equal to bottom, I plus plus, right? With this, result dot add, since you are moving the right, so the right side is common. Which one would be common in this case? The right, that is the column part. So the row part I will keep moving, the column part will remain constant. We are going for this specific column, I right. Okay, and once we have covered this right side, so next time when we are coming from 5 6 7, we don't want to touch 8, right? So we'll reduce the value of right, so we can say right minus minus, right? Now before going forward and printing the bottom, we need to check if there are any remaining rows in the bottom, or we have already covered them from a last move from the top one, right? Because in the end we won't realize whether we have another row available or not. So we'll do a quick check for checking that we still have enough space between the top and the bottom. Okay, so we'll say check if there is a remaining row, and that is to avoid duplicates. Okay, so you can say if top is less than equal to bottom, right? If top is less than equal to bottom, that means we have at least one row, right? So now we can say traverse bottom, also traverse the bottom row. Okay, for now we have to start from this side to this side. Now right was already updated to this one, right? So we can start with int I is equal to right, int I is equal to right, and we'll check I is greater than equal to left, I minus minus. Result dot add. Now which part is constant? This bottom row is constant, right? It's a row and it's the bottom, so we can say matrix, the row part is constant, which is bottom, and I, the column part, is changing. Okay, after this, once we have covered this row, we want to reduce the bottom, so we want to bring it closer to the upper side. For the top we increase it, for the bottom we reduce it, for the right we reduce it, for the left we increase it. Okay, so after this we can say bottom minus minus, right? Similarly, now we'll check for the left side. Check if there is remaining, just like we check for the bottom row. Before performing the bottom row, we have to check if row is available. We'll check if column is available. Remaining column, check if there is a remaining column to avoid duplicates, right? So we'll say if left is less than equal to right. That's a quick check. That would mean at least there is one row. So you say traverse the left, and we'll say for now we are starting from this side to this side, so int I is equal to this, which conversion are we doing? We did the top like this, we did the right here, we did the bottom. Okay, now we are doing the this column again, so from bottom to top, right? Not right. So int I is equal to bottom, I is greater than equal to top, I minus minus. Okay, result dot add matrix. Now which part is common? The column is going to remain same. Okay, and the column is left, I left, right? That's it. Once this side is covered, we want to move the left towards right, so we'll say left plus plus. Okay, that's it, right? And once the while loop is over, we can simply return the result. Let's run it. I hope we do not get any typos today. Great. Actually, it was a very simple problem. Okay, let's run it. Great, beats 100% of the users. It's a simple problem and this is the fastest approach. I think everyone could have used the same approach, or maybe most of them could have or would have used the same approach, right? So that's all from today's video, everyone. And yes, the time complexity is the same for any matrix, that is m cross n. If you have anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.